In this video, I'm going to be showing how to use congruent triangles to prove something. We saw one example in the last video, and I'm going to show a few more examples. In this video, we'll be focusing on proving properties of quadrilaterals. Quick reminder from the last video, CPCTC stands for corresponding parts of congruent triangles are congruent. And the outline of our proofs will be to first of all prove triangles congruent, then use corresponding parts of congruent triangles are congruent to get the parts congruent, and then make our conclusion. We're going to be proving properties of quadrilaterals. So let's look at our quadrilaterals property sheet. Here's our quadrilateral properties sheet. At the top of the sheet, we have the general quadrilateral that has very little structure. As we move down the paper using these arrows, we get more and more structure. The way this diagram is set up is that we have the definition. For example, the definition of a trapezoid is a quadrilateral with exactly one pair of parallel sides. And then underneath the definition are properties that figure might have. For example, the angles formed by a leg and the parallel sides are supplementary. As we move down the figure, properties are inherited from its predecessors. So, for example, over here on the kite, we have a property here that says the diagonals of the kite are perpendicular. When I come down to the rhombus can be thought of as a specialized kite. The rhombus automatically has all these properties. So the diagonals are going to be perpendicular down here in the rhombus. So if I'm proving something about a rhombus, I can assume that I have the properties that are above it in the figure. I can assume that opposite angles are congruent. For example, opposite sides are congruent because a rhombus is a parallelogram. And to kind of simplify things here, I have numbered these properties, and we're going to be proving all of these. When I have 2A and 2B, that means that these two properties can be proved in one proof with one diagram, and these can be proven with one proof. So some of these are going to be done as examples in this video, and some of these will be assigned as homework. So the first example that I would like to do, the first example are these two properties here of the kite. So here's our handout. We're to write a two-column proof. We're going to need to provide our own diagram. Number one, write one proof which will have two conclusions. Prove the following. If the quadrilateral is a kite, then a diagonal bisects two of the angles. And secondly, if the quadrilateral is a kite, then two of the angles are congruent. So the first thing we're going to need to do is make a diagram. The if clause is the quadrilateral is a kite. The if clause is the given information. So now I'm going to draw a kite. Now I need to label my kite. Now the theorem states a diagonal, so I need to determine what that diagonal would be. If you experiment and put in segment BD, it does not bisect the angles, but segment AC will. So here's our diagram. Now, let's see what we have congruent. By the definition of a kite, this segment is going to be congruent to this segment. This one will be congruent to this one. And the diagonal is congruent to itself, so these two triangles are going to be congruent. So let's see if we can write our statements and reasons. First of all, we have a kite, and that's our given information. Now we need to state our congruent segments. Segment AB is congruent to segment AD, and segment CB is congruent to segment CD. The reason here is definition of a kite. Statement 3 will be segment AC is congruent to itself by the reflexive property. Now you can probably anticipate the next step. The triangles are congruent. We need to put the letters in the corresponding order. Triangle ABC is congruent to triangle ADC by side, side, side. Now the angles are going to be congruent, and I think I'm going to number these to make it a little bit easier to write them down. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. By corresponding parts of congruent triangles are congruent. Now I can conclude that two of the angles are bisected. Angle BCD and angle BAD are bisected. This is definition of angle bisector using statement 5. So I have now proved the first thing I'm supposed to prove. But angle B is also congruent to angle D because of corresponding parts of congruent triangles are congruent. So that's going to be our final step 7. Angle B is congruent to angle D by CPCTC, and this is the second thing that we're trying to prove. Now let's go to example 2. In example 2, we're supposed to prove the following. If the quadrilateral is a trapezoid, then the angles formed on a leg and the parallel sides are supplementary. So the first thing we need to do is make a diagram. The given information is that we have a trapezoid, so we need to draw a trapezoid and label it. This is going to be a very short proof. What should the first line of our proof be? ABCD is a trapezoid. This is our given information. It's the if clause of our theorem. What does it mean for it to be a trapezoid? It means that we have a pair of parallel sides. Let's make that statement too. Segment BC is parallel to segment AD by definition of a trapezoid. And now we can make our conclusion. So we have angle B and angle A, as well as angle C and angle D being supplementary. And the reason is, two lines cut by a transversal are parallel if and only if the interior angles on the same side of the transversal are supplementary. In our last example, we're going to do the following proof. If the quadrilateral is a parallelogram, then the diagonals bisect each other. Let's take a look at our property sheet. If we look right here at the parallelogram, we have our definition. and we have 4 properties. And these properties are in a particular order here. And they're in an order that we're going to be proving things. So opposite angles congruent, opposite sides congruent are going to be proven first. And then once we know that fact, we're going to be proving diagonals bisecting each other. So I'm going to be assuming in my proof that I have opposite angles congruent and opposite sides congruent. You're actually going to be proving this as part of the homework, but I'm proving this property right here. The first thing I need is a diagram. My given information is a parallelogram. So let's draw a parallelogram and label it. I also need to put in the 2 diagonals. Now let's make our plan for the proof. I'm going to be using congruent triangles. This small triangle here is going to be congruent to this one. And the way I'm going to get them congruent is by using opposite sides of the parallelogram being congruent. Then I'm going to be using alternate interior angles. The top is parallel to the bottom, and WY is the transversal, which means this angle is congruent to this angle. And similarly, the angle down here at Z is going to be congruent to the angle up at X. So let's write down our given information. We have a parallelogram. Having a parallelogram means the top and bottom are parallel. Segment WX is parallel to segment ZY, definition of a parallelogram. It might be that I also need segment WZ parallel to segment XY. We'll see if that needs to come up later. I think I'm going to number the angles again to make them easier to talk about. So we have angle 1 congruent to angle 2 and angle 3 congruent to angle 4. We could write out the full theorem. 2 lines cut by a transversal are parallel if and only if alternate interior angles are congruent, or we could use a shortened form, alternate interior angles are congruent. So we have 2 angles congruent. Now we need to have the sides congruent. Segment WX is congruent to segment ZY because opposite sides of a parallelogram are congruent. Now we have the congruent triangles. Let's write them down in corresponding order. I am going to need to label the point of intersection. I think maybe I'll label it point A. Now, if I do WAX, the angle that corresponds to angle W would be Y, A corresponds to A, and X corresponds to Z. And my reason here for statement 5 is angle side angle. And now we have corresponding parts of congruent triangles or congruent. Segment WA is congruent to segment YA, and segment XA is congruent to segment ZA. Corresponding parts of congruent triangles are congruent. And this means that the segments bisect one another because it's broken it into 2 equal portions, or 2 congruent portions. The diagonals bisect each other. The reason, definition of bisector. It's important in a proof that the last line of your proof should be the thing you're trying to prove. The then clause of my theorem is the diagonals bisect each other. This is what I'm trying to prove. This should be the last line of my proof. I hope you found this video helpful. Good luck using congruent triangles to prove the properties of the quadrilaterals. Have a great day.